Hello, my name is Beth Dixon, and I work in the math lab over in Behavioral and Social Science building, in the Math and Behavioral Social Science building in room 222 on the second floor. And my job is to tutor math. And today I want to do a couple of examples on multiplying and dividing fractions, something that we all need some help with. And I want to start out with a fairly simple problem, one that we can probably do in our head, but to kind of give us a warm-up on fractions. Let's start out, and we're going to multiply 1/2 times 4. And by doing so, what we're going to get is 2. Because we know that if I have 4 things and I want to give you half of them, that's going to give you 2 and me 2. 1/2 of 4 is 2. But let's see how we do that mathematically. Whole numbers, when we multiply them, should be written over 1. So the 4 is going to be written over 1. Then there are 2 ways we can proceed from here. And it doesn't matter which way that you go. The first way is just to go on and multiply first. 1 times 4 is 4. 2 times 1 is 2. Then 4 times 2, or excuse me, 4 divided by 2 is 2. And remember that as we do this, the fraction bar really means a division problem. You should always remember that because it helps in all sorts of ways. Now, the other way, and it is an or, we don't do both. The other way that we can do this is 1 over 2 times 4 over 1, that stays the same, is that we could have reduced this problem first. And we could have said, is there a way to cancel? Now, I've had math teachers look at me and tell me that cancel is not a very good math term. But it is a very good term that we use and we understand as we do these. We want to reduce the fraction before we start this multiplication process. And in this problem, it probably wasn't necessary. But if we practice with this one, it will make the other problems better. So let's look at this. To reduce a fraction first before we multiply, there's one rule we have to follow. One of the numbers has to be in the top of the fraction or the numerator, and one of the fractions has to be in the denominator or the bottom of the fraction. So the 4 and the 2, one's in the top, one's in the bottom, are both divisible by 2. 2 goes into 4 2 times. 2 goes into 2 1 time. Then we can multiply. 1 times 2 is 2. 1 times 1 is 1. And 2 divided by 1 is 2. So you see that we get an answer either way. Now, one of the things that you'll notice is that I stuck with the traditional time symbol as we did these. And that time symbol was okay in this problem. But as we tend to move toward algebra, an X and a times, well, which one's which? So as we move along with these, we're going to change the time symbol into a dot so that we don't get confused. And so I'm going to try to remember to use my time symbol as we go through this lesson. But we all slip every once in a while, so that's okay as well. Now, the next problem I want to look at is 1/2 times 1/2. Now, this is where I lost some understanding in math. I can remember sitting in 5th grade, and Miss Brady came in and showed us how to do fractions, how to multiply fractions. And I hadn't lost it when she talked about what size fractions were, or how to compare fractions. But I really struggled with this concept. And it was a simple concept she was trying to teach us. We multiply the tops, we multiply the bottoms. There was not even any canceling going on here because we couldn't cancel the 2 and the 2. They were both on the bottom of our fractions, and we couldn't cancel because there was nothing to cancel. My problem was this number was smaller. How can you multiply two numbers and get a smaller answer? Okay, again, I'd had this great concept in my mind that when you multiply numbers, you always got a larger number. Well, remember what I said? 1/2 of 4 was 2. 1/2 of 4. Well, let's kind of keep in mind this. I have a pie. I have half of a pie, actually. I go to a church function and somebody sends half of a pie home with me. But I'm feeling generous and I give you half of my pie. So I divide my half of a pie in half. So I give you half of my half. 1/2 of my half. So this side is mine. And over here, this half is yours. How much of the pie do you have? You have 1/4 of the pie. And when I finally figured that out, fractions made better sense again. But back to the multiplication. Okay, now let's look at another problem. 1/2 times 2/3. In this case, we can cancel because we have a 2 and a 2. 2 goes into 2 one time. 2 goes into 2 one time. 1 times 1 is 1. 1 times 3 is 3. And we get 1/3. Now, if we hadn't canceled, we could have done it as 1/2 times 2/3. And see, there you go again, I forget. And 1 times 2 is 2. 2 times 3 is 6. And we get 2/6. But we can't leave our answer as 2/6. We'll have to reduce that fraction. And if we reduce that fraction, 2/6 becomes, well, what number goes into 2 and 6 is 2. 2 goes into itself one time. 2 goes into 6 3 times. And my answer is 1/3. Okay, let's look at my next fraction. 8/9 times 15 over 16. Okay, again, I want to look for things that cancel. 8 and 15 are both on top. The 9 and the 16 are both on the bottom. So I want to look something top to bottom. 8 and 16 are both divisible by 8. 8 goes into 8 one time. 8 goes into 16 twice. Then we look what goes both into 9 and 15. Notice it doesn't have to be 9 that goes into 15. It can be a number that goes into both of those. So 9 goes into 9, or 9 doesn't have to go into 9. We can pick a number like 3. 3 goes into 9 3 times. 3 goes into 15 5 times. Then we multiply what we have left. 1 times 5 is 5. 3 times 2 is 6. And my answer is 5/6. Now these problems would work the same if they had signed numbers with them. Positive and negative numbers. Okay, now let's look at 3 and 1/3 times 7 and 7/8. Now, to convert this mixed number, remember that we're going to go 3 times 3, which is 9, plus 1 makes that 10/3. 8 times 7 is 56. 56 plus 7 plus 7, Beth, 13 is 63. check my work over on the other page, is 63 over 8. Now we're going to look and see what goes into our numbers here. Now, if we multiply it straight across here, we're going to get some very large numbers. So this is one we really want to cancel first. 3 goes into itself one time. 3 goes into 63 21 times. What goes into both 10 and 8? Well, 2. 2 goes into 10 5 times. 2 goes into 8 4 times. 1 times 4 is 4. 5 times 21, 5. 10, so it'll be 105. And then we have 105 fourths. But since we started with mixed numbers, we want to end with mixed numbers. So what we want to do is divide 4 into 105. 4 goes into 10 2 times. 25 left over. 4 goes into 25 6 times. 24. 1 left over. So that gives me 26 wholes and 1/4 left over. Okay, now let's try one with some sign numbers here. -5 fourths times 3 over 25. Remember I said just a minute ago that this will work just the same with the sign numbers. Okay, 3 and 4 don't share anything that we can cancel, but the 5 and 25 do. So let's divide both of those by 5. 5 goes into 25 5 times. 5 goes into -1 and leaves, 5 goes into -5 and leaves me a -1. Get tongue-tied here. And -1 times 3, -3, and 4 times 5 is 20. So my answer is -3 over 20. And one last example, -3 over 8 times -21 over 4. Well, 8 and 21 don't share anything. 3 and 4 don't share anything. And as tempting as it is to try to cancel with the 8 and the 4 and the 3 and the 21, they're both on top or both on bottom. So we just have to multiply. And a negative times a negative is going to give us a positive. So that's going to be 63 over 32. And in this case, since we didn't start with mixed numbers, it's probably going to be okay unless your teacher tells you otherwise to leave it this way. And I was going to do division, but looking at the clock, I'm out of time. So watch for the second podcast on division, and it'll probably be a much shorter one. And please come by and see us in MBS 222, and I hope this helped in multiplying fractions.